Hi class, this is Course 3, Lesson 62, Graphing Solutions to Inequalities on a Number Line. Okay, so since we're going to talk about inequalities, let's just make sure that we understand that this symbol means less than. This symbol means less than or equal to. And then on the other side we have this one that means greater than, and this one that means greater than or equal to. Okay, so we're going to solve some inequalities and then graph them on a number line. So if we had, oops, sorry, I made a mistake right there. Less than and less than are equal to. The equal to will always have the extra line underneath there. That's part of the equal sign. So we can have something that looks like this. X is less than 4. And if we were to graph that on a number line, you would draw a number line and put just a couple points on there. You don't need to write all of them. But we're going to have a 0 for reference and a 4 because that's the 4. Now, x has to be less than 4, so we would put a circle on the number 4, but we're not going to shade it in, because if I said, if x equals 4, that would mean that that's shaded in. So x equals 4, does that work here? Is 4 less than 4? And that's not true. 4 is not less than 4. So we can't include the point of 4. So we would leave the circle open, and then what I suggest that you do is not try to draw right on the number line that you draw, because that is difficult to interpret. But if you just go up above the number line and draw an arrow, that's sufficient. Now, what this line means, what that arrow means that you just drew, is it's showing you every single solution. All of these points, all of these values, all of the numbers from 4, not including 4, and to the left on a number line are solutions. So I could pick the number -2.5. Yep, that's less than 4. 0 is less than 4. -500 is less than 4. Okay, so this is a graph of the solutions. Now let's do an example with greater than or equal to, just so you can see the difference in the graphs. So what if x is greater than or equal to -2? Again, draw a number line. We're going to put a 0 for reference point and -2. Now, I need the values that are greater than or could be equal to -2. So I'm going to put a circle on the point -2. And since -2 would work as a solution, I'm going to fill it in. I'm going to shade it. It means that this includes the point and this does not include the point. The open circle does not include the point. So -2 is -2 greater than or equal to -2? Yeah, -2 is equal to -2, so that works. That makes this statement true, so I know it's a solution. So where are the values that we could put in for x that would be greater than or equal to -2? Well, they would be this way on a number line. Okay, so those are all of the solutions for the inequalities. So you need to know that when it's less than or greater than, you would have an open circle because it cannot include the point, and these two, when it says or equal to, would be a solid circle because it does include the point. Okay, so let's move on and start solving some inequalities. So we're going to solve and graph the solution to this inequality. So we're going to treat the inequality as if it were an equation. And so the inverse operations are still in play. So we need to figure out where our variable is and then use the inverse operations to isolate the variable. So we would subtract 1 from both sides, leaving us with 3x, because plus 1 minus 1 is 0, so we don't write that. Then the symbol stays less than or equal to 7 minus 1 is 6. Here now we're multiplying by 3, so we're going to divide both sides by 3, leaving this 3 divided by 3 is just 1, so this becomes x, the less than or equal to symbol, and 6 divided by 3 is 2. So there's our solution. It's all values of x that are less than or equal to 2. So we're going to draw a number line. Again, we can use a 0 as a point of reference and put the value 2. Now, x has to be less than or equal to 2. So I know I need a circle on 2, and then I have to decide, does the solution include 2 or exclude 2? So does 2 make this statement true? Is 2 less than or equal to 2? Yes, it's equal to, so I'm going to shade in the circle. And then where are the values for x that would be less than or equal to 2? Well, they would be in this direction. And I can always check a point to see if I drew my arrow in the right direction. So I can pick 0. Is 0 less than or equal to 2? Yeah, 0 is less than 2. So I know I drew my arrow in the right direction. Okay, here's another example, and we're going to work this one the exact same way. So if you feel brave enough to try it, pause the video and come back and see if you got the right solution. So we're going to solve and graph. So instead of rewriting this, I'm just going to write my inverse operations underneath here. So I have the variable x, and I'm subtracting 2, so I would add 2 to both sides. 5 less than or equal to x. Okay, so I'm done. Now I can graph. So I need to put a 0 somewhere and put a 5. And then I need to decide, is this an open or a closed circle? Well, it's a less than or equal to, so I know that it should be closed point to say that 5 would be a solution. Is 5 less than or equal to 5? Yep. Okay, so now we need to draw our arrow. And we need values where 5 is less than or equal to the value of x. And so if I put 0 in for x, does that make this true? Is 5 less than or equal to 0? That's not true, so I need to draw my arrow going to the right in that direction. Now, it may be difficult for you to think through that, and that's okay. What you can do is rewrite this so that the variable is on the left-hand side, and in doing so, you need to reverse the inequality. See how the mouth of, or the open part of the inequality symbol is towards the x? That's where it still needs to be when we rewrite this. So we're going to put an x and a 5, and then we need to make sure that our inequality symbol has the open part towards the x. So rewriting this so that I can say x is greater than or equal to 5 helps you see that the graph goes to the right. So when you rewrite, be careful. Make sure that you get the inequality symbol going in the right direction. Okay, here's another example. Christina is thinking of a number. If she doubles the number, the product is greater than 4. Write an inequality for this description. Okay, so let's say that x is the number. Okay, so what happens to the x number? If she doubles it, well, that would be twice as much. The product, so 2 times whatever x is greater than 4. Okay, so there's your inequality. That's this part right here. Right? An inequality. We did that. Graph on a number line all the possible choices for Christina's number. Now, we need to be careful here because we can't graph yet, right? We need to solve for just x. So we need to divide both sides by 2, giving us x is greater than 2. So we draw a number line, 0, here's a 2. We put the open circle on 2. It does not include that point, so I cannot put, I cannot fill that that circle in on 2. I need to leave it open. So, but I do draw the arrow to the right because I want all the values that are bigger or greater than 2. And so any one of these pairs or any number that is greater than 2 would work, because if I pick 6 and I double that, my product is greater than 4. One last example for you. Let's see, we have Vincent here. He's going to the store with $20 to buy a notebook for $4. He notices that package of notebook paper are on sale for $2. Write and solve an inequality to show the number of packages of note paper he could buy if he also buys the notebook. And we're going to ignore sales tax. Okay, so he's going to buy a notebook, right? So there's $4. Plus, notebook paper is on sale. They're $2 a piece. So I'm going to let x equal the number of packages of notebook paper. Notebook paper packages. Now, you do not need to do this, but if you identify what you're letting the variable represent, that helps you figure out whether your answer is reasonable. You don't have to remember what x is, you wrote it down. Okay, so back to our story problem. We're going to spend $4 on a notebook, and then we're going to buy X number of packages of paper, and they are $2 a piece. So 2 times X, and I have $20, or Vincent does, it's not me. So he can spend up to and including that $20, right? Whatever he buys has to be less than or equal to $20. So let's solve and see how many packages of notebook paper he could buy. Let's see, this would be 16, so there again we're multiplying by 2, so divide by 2. X is less than or equal to 8. So we're going to draw a number line, and this one's going to be just a little bit different. 1, 2, 3, 4, 5, 6, 7, 8. Now, he can buy less than or equal to 8 packages of paper. So I can put a solid circle on 8. And normally I would draw an arrow going that direction because I can buy, that is the solution to my inequality. Any one of these numbers can work. But we are talking about buying packages of notebook paper. So I could buy 8 packages of notebook paper, or 7, or 6, 5, 4, 3, 2, 1. I could even buy 0. Those are the solutions. So it's not always going to be an arrow that you draw, especially when dealing with story problems and anything dealing with a whole number component. Okay? So that is lesson 62, graphing inequalities. Make sure that you have an open circle if it's less than or greater than, because it does not include that value, and a closed circle or a filled in circle when it's less than or equal to or greater than or equal to, because it does include the point in your solution set. Okay? So that's lesson 62. If you have questions, please let me know. I'll see you in class.